Today we're going to revisit differential equations. Now we've done these earlier this year. This is how we solve derivative equations. And we did this earlier this year only in terms of x. Today we're going to take a look at what happens if we're solving a derivative in terms of x and y. In other words, what if we're trying to solve an implicit derivative? We use a special method that we call separation of variables. And it's very easy to do. Let's say we have a derivative, dy dx equals 2x over y. This is an implicit derivative right here, where we have both x and y in the same derivative. So to solve this, what we're going to do is we're going to separate the variables. X is to one side, y is to the other. And I can do this by cross multiplication. Now, side note, this is why we like the term dy over dx. It allows me to separate. I can combine my y's. That's going to give me y dy right here. Equal to, and if I cross multiply here, I get 2x dx. Everything with the y on the left, everything with an x on the right. And now to solve this, we're going to use antiderivatives, because if I have a derivative equation, we use antiderivatives to solve them. By taking the antiderivative of both sides, now the right side's easy, we get x squared plus c1. Now the constant right here is very important. We call it the constant of integration. Very important. If you forget that, you get no points for anything you write afterwards. On the left side, we're going to get y squared over 2. Now, you are right when you say, shouldn't that be y squared over 2 plus c2? You are absolutely right. We're going to get this, y squared over 2 plus c2 equal to x squared plus c1. But remember, we're just going to be adding constants together. And anytime you add constants together, you just get another constant, c3. So the AP test, and everybody else knows, since we already know this, we're okay not having to worry about putting the constant on the left side, because we're just going to bring it over there anyways. So it's okay to leave it like so. But now we're ready to solve for y. In solving for y, I'm going to first multiply everything by 2. We get y squared equals 2x squared plus, now I could write 2c1, right? If I multiply, I get 2x squared plus 2c1. But again, it's just a constant. I'm going to rewrite this as just c2 instead. Now, next we take the square root. And when we take the square root, we got this 2x squared plus c2. We get two answers, a positive and a negative. This is our general equation. In other words, it's a generic equation for us because we don't have our constant yet, which is what we're going to solve for next. Now, it's just like solving for these in the past. If I'm given the initial condition, y1 equals negative 3, this is what we use to solve for C2. I'm going to use this point, 1, negative 3. Now, take a look here. Be very careful. I have two answers, two choices. I'm saying y is positive or y can be negative. If I look at my initial condition here, I'm only going to get one answer because they're telling me y is negative. So when I solve this, I'm only going to use the negative square root 1, not the positive. And now I'm going to plug in my point. Negative 3 equals negative the square root 2 times 1 squared plus c2. Of course, we know the negatives will cancel, and I square it. I get 9 equals 2 plus c2. Therefore, my constant is 7. My equation, y equals negative the square root 2x squared plus 7. And there's our our specific solution, or what they sometimes say, a particular solution right here. So very easy to do. Now let's take a look. All these steps need to be shown on the AP test as well as in class, because if you skip a step, you will lose points, and that's mainly because there's a lot of algebra that they want to make sure you know how to work on these, especially for the next one. All right, now let's take a look here. we have a function right here, very easy, and it's the same idea. We were given a derivative. I want to find the function. So we know we're going to take an antiderivative. Now for this one, I'm going to point it out the same way, kind of like the AP test would. First of all, I'm going to rewrite this. We don't like y prime. Remember, we're going to like dy dx, and that's because it allows me to separate the variables much easier. If I want to separate the variables this time, I have to divide by y. So that's going to give me 1 over y dy. Next, I'm going to multiply both sides by dx. That's going to give me 9x squared dx. Take the antiderivative of both sides. Now be very careful. Again, over here, easy. 3x cubed plus c1. Over here, be careful. That's our natural log of the absolute value of y. Don't forget, you need those parentheses, the bracket, the absolute value symbol here. The natural log of y, you need those absolute value. And again, you don't need to put the constant here because we're just going to add it to this one. Now, this may not look it, but this is our Purdy equation. This is Purdy. Messed up. P e to the RT. We're going to derive this. To do that, we have to solve a natural log. We're going to use a trick called exponentiation. Not a trick, it's just really what we do. Exponentiation. I'm going to make those exponents. And in doing so, the e and the natural log cancel. We get the absolute value of y equals e to the 3x cubed plus c1. You have to show all of these steps. Okay, they want to see this. Now, I'm going to review an old algebra trick, an old algebra skill that you need to have. If I am multiplying bases, I can add their powers. Everybody knows this. What we're going to do is go backwards. If I'm adding powers, I'm multiplying, and we'll see why in just a second. This then becomes the absolute value of y equals, if I'm going to go backwards, this becomes e to the 3x cubed times e to the c1. And you may ask, why would you want to do that? And that's because of this right here. This e to the c1, that's a constant. Oh my gosh, it's a constant. And you're right. We can therefore let e to the c1 just equal another constant, c2. And we get absolute value of y equals c2 e to the 3x cubed. And now we can see Purdy. P e to the RT. Purdy. It's pretty ugly to get Purdy. Okay, moving on. Now, solving this to get the generic, solve for y, we get plus or minus c2 e to the 3x cubed. There's our general solution. We now need to find c2, and they give us the initial condition 0, 2. I get that from here. There's my initial condition. There's our initial condition right there. Now, remember, we have two answers, but this says my y here is now positive. So I can just plug it in. I'm going to pick my positive one. Y equals c2 e to the 3x cubed, and we get 2 equals c2 e to the 0. c2 is 2. So our equation, y equals 2 e to the 3x cubed. Alright, so let's point this out. How would the AP grade you on this one? +1 for separating your variables. You can get +1 for taking the antiderivative, +1 for getting your constant there. All of this work down here just to get this equation, +1. But if you don't have any of these steps, you really don't get much anything afterwards. Knowing to use your constant of integration, +1, and then your final answer, +1. So you get about 6 points, sometimes even up to 7 points on just this alone. Okay? Very easy, but very lengthy. You cannot skip steps on this one. Okay? That's where people go wrong on the AP test. They skip steps on here, and as a result, they lose a lot of points. Same thing in my class as well. Alright, let's try another one here. So pause it right now if you want to, and you can try number 3, and I'm going to go ahead and go over this with you. And unpaused. So I'm going to rewrite this same thing. They give me a derivative. I want to find the actual value. I need the antiderivative. So I rewrite this. I don't like that form. dy dx equals 3, and that's just y. When I separate the variable, I'm only going to bring the y over. I get 1 over y dy equals 3 dx. And I integrate both sides. Here we get 3x plus c1. Over here, again, we get the natural log of the absolute value of y. You need that absolute value, don't forget. Then we exponentiate both sides. Those cancel. We get the absolute value of y equals, remember my little rule here, this is e to the 3x times e to the c1. And we just let e to the c1 equal c2. You have to show all this work. Even though you know what the answer is going to be, you have to show it. Absolute value of y equals c2 e to the 3x. So my general function is this. Y equals plus or minus c2 e to the 3x. And now we find c2. Use the initial condition 2, 4. There's my initial condition, right? I just stopped in. There's my initial condition, and I plug it in. We want the positive only, right? Y is positive, so I have my two choices. Now, so do we need these plus or minuses? Yes, you do. But in the final one, we want the positive only, right? So we can go c2 e to the 3x. And I plug in 4 equals c2 e to the 6. c2 equals 4 over e to the 6. So I write my equation. It's not pretty, but you know what? It's ours. Well, it is pretty. Get it? It's not pretty as an answer, but it is per t, p-e to the rt. Yes, that's what my students deal with every day. So there's our answer. And of course I could rewrite this if I wanted to as 4e to the 3x minus 6 because they have the same base. So take a look here, and on part 2 I will go over a couple questions from your homework with you if you like. Okay, bye-bye.